Welcome to Ask Prep, your trusted companion for NEET and G preparation. Today we will study about a very important topic of physics, which is circular motion, centripetal force and examples. Circular motion is a fundamental concept in physics that describes the motion of an object along a circular path. It is an essential topic in mechanics, playing a crucial role in various natural and artificial systems, from planetary motion to amusement park rides. Understanding the forces involved in circular motion, especially centripetal force, is key to mastering this concept for the NEET exam. When an object moves in a circle at a constant speed, its direction continuously changes. Although the speed remains the same, the velocity changes because velocity is a vector quantity that depends on both magnitude and direction. This continuous change in velocity means the object is accelerating, even if its speed is constant. The acceleration responsible for this change in direction is called centripetal acceleration, and it is directed toward the center of the circular path. In this video, we are going to explore the fascinating topic of circular motion, focusing on the concept of centripetal force and some real-world examples. Circular motion is a type of motion in which an object moves along a circular path. Unlike linear motion, where the object moves in a straight line, circular motion involves constant change in direction. Even if the object's speed remains the same, it is continuously accelerating because its direction of motion is constantly changing. This change in direction is what makes circular motion unique and requires us to understand some fundamental forces that govern it. To begin with, let's talk about the force that keeps an object moving in a circular path. This force is known as centripetal force. The term centripetal comes from two Latin words, centrum, meaning center, and petere, meaning to seek. So, centripetal force is the force that seeks to pull an object towards the center of its circular path. It is important to note that centripetal force is not a new or independent force by itself, but rather it is the result of other forces acting on the object, depending on the type of motion. When an object moves in a circle, it needs a force to constantly pull it towards the center of the circle. Without this inward force, the object would move in a straight line due to its inertia, which is the tendency of objects to maintain their state of motion. In circular motion, the object's velocity is always tangent to the circular path, meaning that it has a tendency to move straight, but the centripetal force pulls it inward, causing the object to continuously change direction and follow the circular path. Now, let's understand how to calculate the centripetal force. The formula for centripetal force is given by F_c is equal to m*v superscript 2r, where F_c is the centripetal force, m is the mass of the object, v is the velocity of the object, and r is the radius of the circular path. This formula tells us that the centripetal force increases with an increase in the velocity of the object or the mass of the object, and decreases if the radius of the circle is larger. The greater the velocity of an object moving in a circle, the greater the centripetal force needed to keep it in its circular path. Let's break this down further with an example. Imagine you are spinning a ball on a string. If you spin it faster, the string must exert a greater force on the ball to keep it moving in a circle. If the string is too weak, it will snap. In this case, the tension in the string provides the centripetal force that pulls the ball towards the center of the circular path. The faster you spin the ball, the more tension is required, which directly increases the centripetal force. Another key factor in circular motion is the concept of uniform circular motion. This occurs when an object moves in a circle at a constant speed. Even though the speed remains constant, the object is still accelerating because its direction of motion is continuously changing. The acceleration in circular motion is directed towards the center of the circle, and it is called centripetal acceleration. The formula for centripetal acceleration is A_c is equal to v superscript 2r, where A_c is the centripetal acceleration, v is the velocity, and r is the radius of the circle. The centripetal acceleration is what changes the direction of the object's velocity, ensuring that it stays on its circular path. It is crucial to remember that this acceleration is always directed towards the center of the circular path, not along the direction of motion. Let's explore a few more real-world examples of circular motion and centripetal force to make things clearer. Consider a car moving in a circular path, like when a car drives around a bend on a road. The friction between the tires and the road provides the centripetal force that keeps the car moving in a circle. If the friction is too weak, like on an icy road, the car will skid and fail to make the turn, which demonstrates how important centripetal force is in maintaining circular motion. Another classic example is the Earth's orbit around the Sun. The Earth moves in a nearly circular orbit due to the gravitational force exerted by the Sun. This gravitational force provides the centripetal force that keeps the Earth in orbit, preventing it from flying off into space. In this case, the centripetal force is the gravitational force, and the object in motion is the Earth. In the case of an object moving in a vertical circular path, like a roller coaster or a pendulum, the forces involved are more complex. At the highest point of the motion, the gravitational force and the centripetal force work together to keep the object moving in a circle. At the lowest point, the object's speed is at its maximum, and the centripetal force is at its greatest. The difference in speed and forces at different points in the circular motion is a key factor in analyzing vertical circular motion. In conclusion, circular motion is a critical concept in physics, and understanding centripetal force is essential for analyzing how objects move in circular paths. Whether it's a car on a curve, the Earth orbiting the Sun, or a satellite in space, centripetal force is the key to keeping objects in motion along a circular trajectory. By applying the formulas for centripetal force and centripetal acceleration, we can calculate the forces involved and predict the behavior of objects in circular motion. As you continue your studies in physics, these principles will form the foundation for understanding more complex motion scenarios in the physical world. Thank you for watching this video on circular motion and centripetal force, brought to you by AskPrep. Make sure to stay tuned for more physics content as you prepare for your NEET exam.